So now in recent videos we used mechanical switches and transistors, wired as switches, NP and bipolar junction transistors, to make an OR gate, as we see here. But here we're going to use an integrated circuit. Since we're using an integrated circuit, we can both source the current with the switch and also sync it, the output being the switch basically. So it can either be a source output or a syncing output, high or low. It's high when it's positive coming out, red LED lights up, and it's low when it's negative coming out, and therefore the blue LED lights up. I grabbed this integrated circuit out of this kit here. They are easy to fry. We're using that 174HC32 right there. Of course, if you look at the actual component, it has more letters and stuff written on it. You know, that should just help you do search for data sheets more than the basic use of the component. So we're using 1 of 4. So we're going to use number 1 right there. We could use any of them, but we're using 1 out of 4 of them. And the inputs that we are not using, I tied to a supply rail right there. The outputs you just leave floating. You don't attach them to anything unless you want them to power a load. Positive supply, top right there, and then ground the bottom left over here. And the OR gate schematic symbol, it's a curve there, and then it kind of looks like an AND gate over here. The AND gate's not curved though, but it comes to a point, although it's a little hard to see that point, but it usually comes up a bit and then, you know, has more of a point, whereas AND is rounded plus the back is flat. So we got 2 inputs because it's a 2 input AND gate. It's quad though, there's 4 AND gates on there. And the basic thing, if we give 2 low inputs, which is actually the ground rail now, you know, pretty close to the ground rail, then we will have a low output. We'll look at that a little more coming up. If we go to the positive supply with any input or all inputs, then the output will be high. Red LED will light up. When everything's to ground, it's going to be ground coming out, and the load is going to be low. So we see that right there. We have the, that's the output up there, the green one, coming to where the 2 LEDs meet. So the output, that's the same as that spot where the 2 LEDs meet. You can see that middle region there. Ground for the red LED, and it's not lit right now. Blue LED, positive supply, so we know the output is connected to ground as good as it can do. Now, these inputs are very sensitive. First off, as we saw, I have, you know, some damaged integrated circuits there. They're the ones that are missing, most likely, unless I happen to stick them somewhere else. They probably got damaged. So before I touch anything that touches this integrated circuit, I'm going to discharge myself by touching the negative supply there. Some people actually put a wristband on where they stay grounded all the time. Now, if I pull that out, okay, even while I'm holding this, I'm not able to, I think I can change it a bit. Will I give myself a voltage? Yeah, maybe I can if I hold it right. But in case, that will give a low input, and then both would be low. Right now it's floating, so both LEDs are kind of oscillating back and forth. I'll turn the lamp dimmer so that it looks a little bit better. So they're not both on, it's just oscillating right there. 1 high input, and we have a high output. Doesn't matter which input is high. Could be 1, it could be the other. Now that we're not floating, we're not getting those oscillations. And I can turn the trim. I'm going to do this quick. We got a high input there. Now, if I go like halfway, then we will actually get like both LEDs lit up. So I like to do the trim pot here, just kind of a test. See if there's like some hysteresis or something, or if it just flips in a certain spot. But there you can see they're probably oscillating there back and forth, and you know, that's probably what they're doing. But down a little bit, we got all this over here. That is a low input, and then all this up here is a high input. But right in the middle, there's kind of an iffy middle ground region. Now, of course, if I go high with the trim pot and high with the jumper, that also keeps the output high. So here's a closer look at the diagram I drew a long time ago. We have the OR gate truth table, as I talked about before. If any input is high, the output is high. And we actually have a low output here. Those switch-based circuits we had, either the switch was on or off, and the load was either on or off. Now we can actually source current or sync current with the output. So it's better to say high and low for the most part. And the output probably doesn't get, especially when you're lighting LEDs, all the way to 0 volts, and might not even get all the way to 5 volts. But as we saw with the trim pot here, you know, we can just have in the range, you know, you can see this input really close to 5 volts there, down to a little more than 2.5 volts, and then a little less than 2.5 volts to 0 volts. That's our low area, big wide area, and then up here, big wide area. We just have like a real small area where we're in kind of an iffy position right there. So just be aware of that. We could have something that's a Schmitt trigger output when it comes to a voltage. You know, go high and low, it falls short to the rail. Doesn't matter as long as it's not real close to the middle. And so yeah, there's 4 of them on the integrated circuit. When you have these 7400 series integrated circuits, always check the data sheet, but generally speaking, the input should not be left floating. The output can oscillate. It can cause problems with the integrated circuit. So usually they say you can go to either the positive supply or the negative supply with each input. And I kind of doubled them up just to make it easier to track what's going on here. That's the 2 inputs for one OR gate. That's the inputs for that OR gate right there. So I just used the same jumpers, and there's only so many of these jumpers. I don't have enough to make them all the same one. But yeah, I got positive and positive for that one, negative and negative for that one. I could do positive and negative with one. That's okay too, as long as each input has a solid positive or negative voltage. Hopefully that makes sense. And again, you leave the output floating. And one way to tell if you're doing a good job without having like oscillations and stuff is how much current is flowing. So it's probably about 2 milliamps of current that's powering the blue LED. When I pluck it, we don't have any waste current going on here. So now to save time, I reinserted the blue LED and used these pliers to pluck out the jumpers. We do have, it looks like a little bit more current showing on there, probably due to like oscillations and stuff. But you know, this one isn't running out of control as much as a lot of them when I pull these. So you can't always tell for sure. With those unused inputs, put them to a supply voltage. You could also use a resistor instead of a jumper, making a direct connection. But in case, yeah, I covered pretty much everything. Learn all you can about the 7400 series integrated circuits. There's also the 4000 series. I'm using the high-speed CMOS. They say HC. That's what that whole kit was right there. I have a second kit too, though, for the ones that I probably fried. Like if I fried this one, I probably got one in that second kit. And because this kit's the one where I leave the empty spaces. So I probably have that one for sure. But in case, if you fry them, it's good to have a second kit. They're really easy to fry, and discharge yourself before you use them. But there's also like 74 LS, low power Schottky, a 32. I probably got those two. I got an LS kit. But those are like older versions. These are the improved versions. So just be aware of that. But in case, yeah, that's really about it. Thanks for watching. Make sure you check out one of the other videos I'm posting to the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.